Herkese tekrar merhabalar.
Hi everyone. We are in the second session of academic day, and we have Professor Dr. Hatice Sözer, faculty member at Istanbul Technical University Energy Institute. I will introduce her shortly. Professor Hatice Sözer completed her undergraduate education at İTÜ Faculty of Architecture, her master's degree at Colorado University, her doctorate education at Illinois Institute of Technology, University of Chicago. She has advanced research and practical experience in sustainable design, efficient energy efficient buildings, the integration of renewable technologies into building designs. She has many journals, conference publications, national and international projects and awards on these subjects. As an example of research projects, two large-scale projects she has completed, financed by the European Commission on smart and energy-efficient renewal of existing buildings at neighborhood scale can be shown. Welcome.
Teşekkür ediyorum. Hoş buldum.
Hi.
İsterseniz sunumunuzu paylaşın.
Şu an sunumumu görebiliyor musunuz? Ekranda çok emin değilim. Görebiliyor musunuz?
Can you see my slides right now?
Geldi ama tam ekran değil hocam.
It's not in full screen.
Paylaştığını görüyorum.
I see that I share and it's full screen on my screen.
Slaytlarımı değiştirdiğimi görebiliyor musunuz?
Yok, şu an.
Can you see that I'm changing the slides?
Evet, arkadaşlarımız paylaşıyor şu anda. İsterseniz.
Our friends will share.
Siz kaldırın hocam, arkadaşlar paylaşsın. Siz ekrandan takip edebilirsiniz.
You can follow through the screen while our friends will share. In the overview of our outline of our presentation is that I'll start with definition of building envelope and function of the building envelope and also elements of building envelope and also the effects of the comfort conditions and energy efficiency and the ways to improve the building envelope. When we say building envelope, we actually talk about the covering, the coating and protection of the building. When we say this, and it separates from the indoor to outdoor. For example, once the external conditions, rain, snow, and the wind, and there is the conditioned environment. When I say yes, you can just continue with the presentation. According to the dried, heated, and cooled environment is separated from the external environment. And it shows the separator, which makes it easier for the climate control. The design of the building envelope is only made by the architectures and engineering, but it's not only related to engineers. Both architectures and engineers can work together. So the category can be in three ways. When we look at the functions of the building envelope, there are many functions of that. We can divide them into three categories. The most important one of them is the support. So this is all the for ensuring support to be resilient to dynamic internal and external power, and also to transfer this. And at the same time, it provides a control. The control is against the external and internal loads, and it also regulates the performance of the building. When we say performance, as we are going to energies, I'll talk about energy preservation, heat performance, air tightness, and also the impermeability of air, ensuring fresh air, and also fire safety, and also acoustic performance being better. In order to ensure all these conditions, it provides a control, and that's one of the important functions of the building envelope, and it is aesthetics, and this is important for the buildings and for everyone. This is one of the other factors which is important. But while talking about these functions, so the performance is very good, or very aesthetics being very good, or having a very good support cannot be taught separately. All of them have to be made optimized in a certain level, and for that, all the materials and all the techniques that are used, their costs should be sustainable, and of course, the feasibility should be taken into account in the design of the building envelope. So, in all of the designs, there needs to be an optimization. If we go into details of the functions of building envelope, there are, of course, protecting the building from the environmental conditions. When we say environmental conditions, the most important one of them is that when we are talking about the envelope of the building, the precipitation control. Once again, I'd like to say that in my presentation, I always talk about the conditions which are related to energy. Therefore, the precipitation load is very important. When we say precipitation load, could be rain and could be snow loads, and of course, the indoor conditions that we are trying to ensure inside the buildings can be looked at how it should be taken under control, and also it's about how we make it the design, of course. When we identify building envelope with the types of precipitation, the roof tops are the most important element of the building envelope. So we think that it is the with roof, it also transfers the snow, and if there are just flat roofs, in order for them to go downwards, so we don't do it this way. There's always the curve. There's like 15% curve and inclination we provide, or 10% inclination we gave, and also it's so important the facade of the building and the floor of the building, the ground foundation of the building should be affected by not only the snow and rain in the right manner. So it should be designed in a way to be protected from all these, so that these precipitation loads and the moisturizing effect should be outside the building, that it will protect the indoor environment from these precipitations. This is such a function of the building envelope. When we say rain load, it is about the water. In order to, there should be drainages in this regard, and so while we select the building envelope against these natural effects, The building envelope should be selected accordingly. Insulator, barrier, and drainage and surface tightness walls should be used. Water insulation, as you can see, can be applied here. This is not only the insulation material; it is also with the drainages. It is very important to have the fringes or overhangs and cornices is important with the soft fits, and it is there are strategies to prevent the rain to be touched upon by the surface in order not to have the rain inside. At the same time, controlling the precipitation as we want this, so we have to have the sun under control. The sun control can be done with the energy control. There are two criteria. The first one is the daylight. So it is to have the glares and protection from the glares, and also the illumination control and UV protection. We see that these windows are the ones which are used for the controlling of the sunlight, and there is also the flow of the heat is important. There are two types of these. But there is a diffused with the diffuse beaming and also conduction. And the heat reaching the building. With the building envelope design, it can be taken under control. At the same time, the elements of a building envelope, different envelope building envelope elements. There shouldn't be any leakages. There could be leakages because of the in the walls, and there could be the heat gains, and at the same time, because of the heated air going upwards, there could be a flow of heat. All should be in the controlled manner. The controlling of the building envelope this way has certain effects on the energy performance, and at the same time, for example, there should be purification of the moisture and humidity, and also prevention of the water leakages, and also the durable and resilient envelope building envelope are all effective. And as I told you, the elements of the building envelope, we have to if we are to tell them for the physical components, so we see the external walls, the doors and windows, and the roof systems, and the undersurface coating, and also the foundation, which separates the internal and external environment. These are called the building envelope elements, and at the same time, there are the chimneys and can be used, can be taken as the elements of the building envelope. Of course, the assemblies of these parts and the parts can be taken as the elements. When we say the elements, the wall material, there might be more than one wall material, and based on the functions, the materials can be different as well. I mean, the carrying element material, or for example, the walls materials could be different from each other. Therefore, these all and their functions are important in terms of building envelope. Their interactions in terms of building envelope and heat gain can be different. When we look at the comfort conditions, so when we look at these conditions, comfort conditions, the comfort conditions can be there, and it's about what we feel as comfortable. So although there are of course the conditions that we create inside through making use of the conditions outside, there could be a certain humidity, noise, ventilation, carbon dioxide, and also ventilation and illumination and heat levels should be there. This is how we ensure the comfort conditions inside or indoor. So therefore, with the comfort conditions, with when we look at what is the effect of this on the ones, we see that there are the heat comfort conditions. The heat, of course, there are, when we look at its effect on the design conditions, we see that first we need to look at the heat comfort conditions. So what are those? These are the factors: metabolism speed, clothing insulation, ambient temperature, the radiant temperature, the air speed, and also relative humidity. So when we look at these in the indoor conditions, we see that the 12 to the 22 Celsius degrees are the ones which we feel comfortable. Of course, the reason why there are these changes, it's about the metabolic changes. So with the youngsters and the ones, the all elderly people, and there's also the temperature heat that they feel are different. And in the activities, we saw that. For example, for a person who is making the movements in a gym, and the person who's sitting in the offices can present differences based on this. So also the clothing or the clothes that we wear have an important is an important factor for the temperature that we feel. It is normally the 20. If it is more than 0.25 per millisecond per second, so it affects in the humidity should be 30% to 70% that we feel comfortable. And the fact that the temperature is certain level and it should be homogeneous, that is very important. If we think that the heat, if we feel the heat is a different, if for example the temperature degree between the internal wall and the window, if there is a difference between this, and if we feel this, we can feel uncomfortable in the indoor environment. Therefore, the objectives show that if there is the difference there, we feel uncomfortable, and also this affects our situation as well. It also affects our productivity. And the fact that it is very high or very low is affected. And when we look at the comfort conditions, the relative humidity also has an effect on the feeling of comfort. So the ones the temperature and also humidity affect our productivity, and also has a positive or negative effect on the productivity of ourselves. Yes, when we say that the heat difference or temperature difference, if there's a temperature difference and if we feel that there's a difference there, there could be some negative impacts of this. For example, the temperature of the head and temperature of the food is food is different. It's about having a pan, it is hot and it is transferred to our body. We can feel muscle pains and other flu-like symptoms. Of course, all these are important in our system of the building envelope. In order to get rid of these, the temperature should be homogeneous, and we have to be careful of this. Accordingly, if the floor is very cold, for example, in the bathrooms, for example, when we just go out of the shower, we see that the floor is cold. It makes us feel uncomfortable. It's about the material. It's about selection of the material when we design this. And there could be such differences, and we of course we have to look at we can eliminate the material selection according to our comfort level. Of course, the airflow is important as an important factor, as we can say that there is the air movement is there, and regarding that, there is the partial cooling of this, and we all experience this, and this causes the flu-like symptoms and muscle pains. So in the ventilation, as we want to make use of these, what are the levels of this is important. If you are to make a summary of this, of course, while designing the building envelope, it is about how you take the air inside, and of course, from the walls, the air quality systems are important, and the heating it can be from one certain part of the air ball, and this cause uncomfortable and uncomfortable feeling of uncomfortable, and with these systems, there could be non-homogeneous systems, and these are all important, and this could cause uncomfortable feeling. Based on the research that is conducted, if there is this temperature difference coming from the surfaces to the ceilings, whether it is hot or cold, and also, of course, our bodies having perceiving this, if it is more than 5 centigrades, then it makes us feel uncomfortable, as can be said. And when we look at the building conditions, when we look at the energy performance effects, what we have to pay attention is that it is the envelope of the building. While designing this envelope, it's about how we will position our building, and this positioning, it can be geographic, and also at the same time it's about the direction, the orientation of the building. So it is about how we benefit from the sun and from the wind. It's about the positioning of the building, management of the building, and this all actually affects, this is one of the most important criteria that affect the energy efficiency of the building. When we look at the different climate zones, we see that there are differences in the building envelope. For example, the climate conditions, when they become too extreme as a condition, the building envelope can see that there is no open gaps between this. When the climate conditions are more tolerable, that the building envelope is more permeable, and also it is designed for better use of the external conditions. And if there is a dry and hot climate condition, the envelope, building envelope there, and the building envelope with the more tolerable climate condition are different in terms of the material that is used, and also we see that there are different gaps in between. And here in these areas, it is about there can be more of the areas, and of course so we can see that there is the humidity inside. The shading elements can be used, and when the roof is very airtight, we can see that in dry so we see that the roof is not used very much.
So the thermal mass is higher. That means it has heat capacity. These are the materials that are used, and that's what we can easily observe. Therefore, the building envelope and climate conditions are directly connected to each other. And there might be different climate change with same building characteristics and features. We see that the buildings in Switzerland are similar to the buildings in the Black Sea region because of the heavy rain and because of the performance there. And the facade materials that are resistant and strong enough to resist this rain, and especially in cold climate area, what we see that in order to get benefit from soil heat, in some cases houses are built under soil. We have some cases in the province of Kars in Turkey. That means there are similar characteristics depending on the climate conditions. In New Orleans, these building envelopes are similar to the building envelopes in Muğla province. Because of the similar climate conditions, and we have balconies and we have terraces here in these two buildings, and we have also atrium and also trees for shadowing purposes, and also houses in the Middle East, and also the houses in Mardin, the city of Mardin. They are quite similar because of the hot weather conditions, because of the temperature. And we see there are similarities, and there are also elements to create shadow. As regards to the energy efficiency, we are talking about this issue. The material is important, and how we calculate heat, and also the materials conductance is important for us. Conductivity is very important for us, and also the thermal conductivity of these materials are very important for us as a criterion. This is what I just told. And in addition to this material, the type of these materials, we should pay attention to the area that these materials cover, and also the difference between exterior and also internal and interior heat. These are the criteria that we use in our calculation. Of course, all materials have this energy performance certificate, and we use this. I don't want to go into details, but we use the U value when we talk about heat performance, and we will see this performance. This U value is the most common one, and that we always see whenever we talk about heat performance. And it's thermal conductivity, and that means the conductivity coefficient, and so while we are selecting our materials, we need to look at their thermal conductivity performance, because this thermal conductivity performance is the key issue to be considered. And in winter and in summer period is important as regards to climate change, because we know that heat moves from hot areas to cold areas. That means if we heat inner part of the house, then if the outside is colder, the heat will move to the outside. This is why we need to prevent the heat loss. And if there is, for example, 22 Celsius degree within the house, and if it is colder than 22, then the heat will move to the outside. This is why we need to design the building envelope in line with this principle. As I said, while we are selecting, we need to look at this specific heat, and it's also specific heat capacity, its density, and also heat conductivity. Of course, each material, each material has different values, and we need to make our decision based on the quality and also the features of these materials. As I said, we need to calculate the summer period and the winter period differently. But while we are selecting materials, we have no chance to change these envelopes during the winter or during the summer. That means we need to select the most suitable one. So we need to have materials which has high capacity of maintaining heat in it. And if we have this material, for example, for the summer, then this material will store like natural stone or other materials that have high capacity. It will store heat from the sun, and when the sun sets, the material will still use it. So these materials are important for the heating purposes, and we can use these materials for heating purposes. And it can, especially if there is a high difference between the daytime and nighttime, such materials might be used very effectively. And also we have these summer conditions and we can still benefit from this. And on the contrary, we can have some elements to create shade for shading purposes. Yes. So we can direct the heat of the house into the ground, and then we can use them when there is no sun, when the sun sets. We can have this natural ventilation to transfer this heat to the outer walls of the building. And of course, while we are designing such buildings, we also need to look at the equipments within the building, because we need to pay attention to their impact on the heat performance. And also even our body has certain amount of heat, especially in the summer period. We need to look at the interior design of the building and also the equipments of the building. And also we can calculate our designs based on the heat recovery and the heat loss calculations, especially existing buildings when they are renovated or when we design new buildings. We need to look at the building envelope and also the insulation materials that we use, because using the insulation materials, when we look at the coefficient, we see that these are usually low values. So when we add additional materials, then we improve the condition, then we improve the situation. Another criteria that we need to take, what will be the thickness of this material? Of course, we will make decision about the thickness depending on the heat values within the house and outside the house, within the building and outside the building. As you see on the slide, it is -10, for example, and depending on the thickness of the insulation material, we can change the situation. We can improve the situation. If it is a thin one, then it is 10. If its thickness is middle, then it is 18. And if we use a thick one, a really thick one, then it is 20 Celsius degree. That means if we want to keep the temperature at 22 Celsius degree, then we need to pay attention to all these values. And of course, the temperature of the wall should be close to the interior temperature so that we can achieve it and we can maintain this comfort. Therefore, we need to look at the way how the heat enters into the building. Of course, we also pay attention to the insulation process, and insulation materials will be used both in the summer and also in the winter time, because we cannot remove it in the summer period, for example, or in the winter period. So we need to make our decisions based on all these criteria. We can discuss if it is towards the inner part or to the outer face. So we need to decide the location of the insulation materials, whether it should be the inner walls or exterior walls. There are many criteria to consider, but the material that we are going to use is important. When we look at this issue, if it is -5, for example, and if the insulation material is applied to the exterior wall, then it will increase up to 10 Celsius degree. And if, for example, the outside temperature is 35, and if the insulation material is applied to the interior wall, then it reaches up to 18 Celsius degree. So the heat difference that our building wall is subjected to may reach up to 5 Celsius degree. If we apply it to the interior wall, our exterior wall is subject to the cold or hot weather conditions. And the heat difference that needs to be tolerated reaches up to 30 Celsius degree. So if we apply it to the interior wall, we should consider this fact. And also balconies, which are an element of the house, of the building, if our insulation material is applied to the exterior wall, we need to apply these insulation materials to the balcony as well, because it is important because since this balcony is part of the building, if there is no insulation, if there is no insulation material, the heat will easily enter into the building. So we can cover the balcony by the insulation materials that we are applied to the whole house. So the building envelope materials are important. And if there is any heat loss, we can use thermal bridges to prevent heat loss. While we are designing the building envelope, the materials and the coefficient of the conductivity is set by the TS 825 because TS 825 sets the rule for the insulation, for the heat insulation for the buildings, and Turkey is categorized according to the climate regions, and the windows, walls, roof, and also the basement values are calculated and are published by this TS 825. That means while we design the building envelope, we need to have some strategies. That means we need to pay attention to winter conditions and also summer conditions. And also we need to look at the winter conditions. For example, and summer conditions as well are important to decide the insulation materials. And we need to look at the U value, that is the heat conductivity value. And we can use these type of materials that can prevent the heat loss and we also need to get maximum benefit from the sunlights during the winter period. As I mentioned before, and we have these materials to balance the heat difference between inside and outside the building. And we can benefit from natural ventilation. That means any decision that we made is directly related to our objective. If we want to improve or reinforce the building envelope, what we need to do first is as follows. We need to determine and identify the current status. Then we can make decisions about the materials that we are going to use. And we can use thermal cameras, especially in the period that the building is heated. And we take photos of the building from a location that is outside the building, and we can detect the heat loss locations, or we can detect which rooms are colder, which rooms are higher. And if we see that there is an extreme heat or extreme hot or cold values, then we will realize that there is a problem with the building. And we also have simulation programs which we can take a picture of the building in a dynamic way. And we can calculate all the values, all the required values, so that we can get monthly values, monthly consumption values of the building. And we can, for example, find the values, reach the values of the lighting values or ventilation, and also the thermal recovery for cooling or for heating purposes. We can use these type of simulations to develop our strategies. This is a detailed calculation that we made for an EU project. And in this building, the living room, which is close to the exterior facade, and we decided that the window was too small to get enough daily light and natural light, and it was also negatively affecting the heat consumption, and also it was not useful for natural ventilation. In order to improve the condition as regards to natural light and also ventilation, it is important to pay attention. Therefore, I don't know whether you can see or not, but there is an element to shadow, and also we had some shelves to reflect the light that comes from outside the building, and we aim to reflect this light to the roof of the house. That means we need to identify the current situation, and our solutions should be based on our findings. As I said before, the building envelope, especially for heat performance, isolation performance is very important, and we need to be careful about the leakage in the locations of the assemblies, that different materials are connected to each other. And shading elements are important. The shading elements are important building envelopes to prevent heat loss. And the selection of shading elements are important. We need to know all the details, the sunlight directions, and also we need to know the materials of these materials, whether we will apply them in a vertical or in a horizontal way, alternatively in both vertical and horizontal way. And we will use all these shading elements. So we can when there is an extreme weather conditions, we can benefit from this issue. And it is important for the inner comfort conditions. And we can design this building envelope in an optimal way, because we can reduce the indoor loads and workloads. And if we use these mechanical systems, and that means the cooling and heating systems, we can improve our conditions. We can benefit from different technologies, these automation systems like the shading elements, etc. We can get benefit from all these issues. So we can consider all these issues, and we can also make conditions, and we can make calculations which have important effect on the energy consumption values. My final point is as follows. We should not design the building envelope in a separate way than other elements, because we cannot examine it in an isolated way, because we need to pay attention to wind, sun, and also other locations. And we also should be careful about the materials. So it is not only the thermal performance, but also in addition to thermal performance, we should be careful about their relation with nature. While we design a building, we need to look at the building needs and how we can meet these needs. And we can think about how to generate energy, how to meet the need for water. But these are the issues that we get from nature. But when we use them in building, how to send them back to nature and how to get them from nature again. So it is all about the thermal performance. And we also need to look at when the building life cycle is over, it should not harm nature. And we should also have information about, or some predictions about, the building waste when the life cycle is over. So we need to identify the existing energy resources and the existing options. So you can move to next slides. So the way how we benefit and also the way how we use it in the building. And after we use, how do we send them back to environment? How do we send them back to nature? These are important factors to take into consideration. So it is not only the building envelope, although we may think that it is only the building envelope, everything is intermingled, everything is independent. Everything is dependent on each other, sorry. Therefore, so the energy performance is affected by the building envelope, and while we calculate this capacity, we need to know the existing situation, the existing values, and the location of the building is important, because the building envelope is directly related to environment, the location of the building, its physical environment. And if, for example, if we have a building which is higher than our building, then there will be no wind, for example, or some buildings may prevent the winds. So the fossil use of energy needs to be reduced, and we should ask how. And all these issues should be examined and should be considered while we design it. Thus, we can have a balanced consumption of energy and also consumption of materials. After all these, we can calculate the situation, or we can make predictions about the winter and the summer periods. Following this step, we can go into details for this thermal bridge, how to prevent the heat loss, and we will also decide the layers of the building envelope. Therefore, we need to have a holistic approach in our design, and we need to design at the city level first, and then we need to move to the material level. That is the decision. Thanks for your patience. I hope I didn't take too much of your time. Thanks a lot, dear professor, for this valuable presentation. There are questions. Unfortunately, we are running out of time because next session will begin in 15 minutes. You can see my email, so you can email me at any time you wish, and I will be happy to answer your questions. And I will be able to exchange emails about all these issues. Sorry for taking too much time since I was not able to control my presentation, my slides. Thanks a lot. So you can ask. So we would like to inform our participants to send their questions via email to you. So hope to see you next time. Thank you. Thank you.